On number 28, we have the region D that's bounded by these 4 lines. It's a parallelogram. It's the region inside here. So let's think about what's going on here. So part A says there's a very natural change of variables to use here. And so the thing to realize is that this region here, we can say, okay, x plus y is equal to 1 is this line, x plus y is equal to 4 is this line. So the region has x plus y is between 1 and 4. Negative 2x plus y is 1. Negative 2x plus y is 7. So negative 2x plus y is between 1 and 7. So why is this suggestive of change of variables? Well, we call this u. This will be u is from 1 to 4. So then we should call this v here. So that's the answer to the first part. Is v needs to equal negative 2x plus y. Okay, so we have u is equal to x plus y. We have v is equal to negative 2x plus y. We want to solve for x and y in terms of u and v. Okay, how do we do that? I'm going to subtract the second equation from the first equation to get u minus v is equal to x minus negative 2x is x plus 2x is 3x, y minus y is 0. So u minus v is 3x, where x is equal to u minus v over 3. So hooray, we have x written in terms of u and v. What else can we do here? What else can we do? We want y in terms of u and v. So looking at this first equation here, u is equal to x. X is u minus v over 3 plus y. If we subtract this term from both sides, we end up with y is equal to u minus u over 3 is 2u over 3, and we end up with a plus v over 3. So here is x in terms of u and v. Here is y in terms of u and v. And we can use this in part C to find the Jacobian of our map here. So to do this, we want the partial derivative of x with respect to u is 1/3. Partial derivative of x with respect to v is negative 1/3. And the partial derivatives of y with respect to u and v are 2/3 and 1/3. So the Jacobian here is 1/3 times 1/3 is 1/9 minus 2/3 times negative 1/3 plus 2/9 is 1/3. Okay, so then finally use our change of variables to evaluate the integral in question here. And so this integral is going to equal u runs from 1 to 4. V runs from 1 to 7. The original integrand is x plus y, but x plus y is here is u. So we can just plop that in here. Then we need to multiply by the Jacobian. It's actually the absolute value of the Jacobian, but here 1/3 is positive, so we don't have to worry about that, times 1/3 dv du. And this should be a relatively straightforward integral to evaluate here. So, I'm integrating with respect to v first, not with respect to u. So the antiderivative of this with respect to v is uv over 3, plug in from 1 to 7. And so we'd end up with 7u over 3 minus u over 3. And so that's going to be 2u du. So we'd end up with u squared, plug in from 1 to 4. So 16 minus 1 is 15. Okay, so what's the moral of the story here? Maybe the moral of the story is realizing that these bounds here make very, very good suggestions for what change of variables to apply.